Components of velocity in spherical. Components of velocity in spherical polar coordinate system. You let this is the y-axis and this is the z-axis and this is the x-axis, and we let a point P and this is the origin point. All vector is perpendicular to each other, and we draw a line point O to point P. This is the vector R. And the mirror image of vector R draw on the plane XY. Draw on plane XY. Then this is the mirror image. This is the y-axis, and we meet this line parallel to this origin to P point, and then the value, and we draw a line to x-axis to this mirror image. This is the angle theta. Angle, and this is the angle phi. Then the value of this line is r sin theta, and this value y equal to r sin theta cos phi, and x equal to r sin theta into cos phi, and we draw a line to z-axis to point P. The value is z equal to r cos theta. The position of a point P in a coordinate system can be specified by the single vector. The displacement of the particle relative to the origin O of the coordinate system. This vector is called position vector of the point and denoted by OP. Vector OP equal to vector R. It gives the magnitude as well as direction of displacement. If R is the unit vector along the direction vector R, then vector R equal to R unit vector R. If R comma theta comma phi, if R comma theta comma phi are the polar coordinate of the particle P at any instant, and x, y, z the corresponding Cartesian coordinate, then x equal to r sin theta cos phi, y equal to r sin theta sin phi, z equal to r cos theta. As shown, vector r equal to xi plus yj plus zk. Displacement. Vector r equal to r sin theta cos phi I plus r sin theta sin phi j plus r cos theta k. Then the value is unit vector else, but unit vector equal to vector upon magnitude of vector, mod of vector. Then the unit vector r equal to sin theta cos phi I plus sin theta sin phi j plus cos theta unit vector k. Cos theta unit vector k. Since the unit vector theta in the direction of increasing, theta is at right angles to unit vector r. Theta is right angle to unit r. Theta angle is right angle to unit r. We can differentiate this equation. Then as respect to theta, we can differentiate this equation as compared to theta. Then theta unit vector theta equal to cos theta cos phi. Cos theta cos phi I plus cos theta sin phi j minus sin theta into unit vector k. As unit vector phi is at right angle to components r sin theta and lies in the xy plane. As unit vector phi is at right angles to components are sin theta and lies in the xy plane. Phi is at right angles to the components r sin theta. And lies in the xy plane. Then the value is unit vector phi equal to minus sin phi I plus cos phi j. Velocity is the time rate of change of displacement. Velocity equal to time rate of change. Velocity equal to time rate of change of displacement. Then vector v equal to vector dr upon dt. Vector dr upon dt equal to d upon dt. The value of vector r equal to r unit vector r equal to. We can differentiate this value. Differentiate of first part. This is the first part and this is the second part. Differentiate of first part. d upon dt r and left second part plus differentiate of second part d upon dt unit vector r into left of first part. Then d unit vector r upon dt equal to d upon dt in bracket sin theta cos phi I plus sin theta sin phi j plus cos theta unit vector k. We can differentiate this value equal to cos theta cos phi into differentiate. The differential value of sin theta equal to cos theta and cos phi and differentiate of theta equal to, this is the differentiate of theta, minus sin theta sin phi differentiate of phi. This is the unit vector I plus cos theta sin phi, theta differentiate plus sin theta cos phi into phi differentiate j minus sin theta differentiate of theta into unit vector k, then the value is differentiate of theta cos phi I plus cos theta sin phi j minus sin theta unit vector k plus sin theta differentiate of phi in bracket minus sin phi I plus cos phi j then d unit vector r upon dt equal to theta differentiate of theta into unit vector theta plus sin theta into differentiate of phi into unit vector of phi. Then the vector v, time variant, vector v equal to differentiate of r unit vector r plus r differentiate of theta unit vector theta plus r sin theta differentiate of phi into unit vector phi. The above relation can be put in the form. Vector v equal to vector vr plus vector v theta plus vector v phi. Vector v phi. Physical significance. Now, VR is the velocity along R. VR is the velocity along R. VR is the velocity along R, along vector R, comma. V theta, the velocity along theta, velocity along theta and velocity along theta and v phi the velocity along phi, v phi the velocity along phi, velocity along phi. The three velocity vector Vr, V theta and V phi therefore act as three orthogonal components in the polar coordinate system in the same way. Vx, Vy, Vz are rectangular components in the Cartesian coordinate system. V square further vector v square mod vector v square equal to vector v dot vector dot square plus r square theta dot square plus r square sin square theta phi dot square equal to v r square plus v theta square plus v phi square, where v r equal to mod vector vr, then vector differentiate of r, then v theta equal to mod of vector v theta equal to r differentiate of theta, v phi equal to mod of vector phi equal to r into differentiate of theta, comma gamma v phi equal to mod of vector phi equal to r sin theta into the density of phi. If a particular travels only in a straight line as it has the linear velocity vr. Linear velocity vr equal to differentiate of r into vector r. If moves along a circular path with a uniform velocity, it has only angular velocity. If a particular travel only in a straight line, if a particular travel only in a straight line, it has only the linear velocity vector v r equal to differentiate of r into unit vector r. If it's moved along a circular, this is the linear velocity. If moved along a circular path, if this is the move along a circular path with a uniform velocity, it has only angular velocity. V theta, vector V theta equal to r differentiate of theta into unit vector theta, where r is the radius of the circle, and theta differentiate of theta, the rate of change of angle. If the particle moves along a curved path in a plane, if particle moves along a curved path in a plane, it has both the components v r along unit vector r and vector v theta along unit vector theta. Unit vector theta at right angles to r. At right angles to r. When the particle moves in a curved path in space, it has addition the third component. If when the particle moves in a curved path in space, it has in addition the third components r sin theta phi differentiate of phi. R sin theta differentiate of third component r sin theta into differentiate of phi in the xy plane, perpendicular to yz plane, in which unit of vector r and theta lies. R sin theta is the component vector r in xy plane, and r sin theta and phi gives the angular velocity due to rate of change of phi in the direction phi perpendicular to vector r sin theta. A unit vector in the direction r sin theta is dependent by unit of vector rho. Okay, thank you.